Hi, welcome to this section of treating questions on arrays and HashMap. In our previous lecture, we talked about some basic concepts involving arrays, and we say arrays are fast for push and pop, they are also fast for lookup, and they are ordered. We also talk about some of the cons of array. We say that arrays are slow for insert, they are also slow for delete. So if you haven't wanted to watch that video, check in the description below. The link is in the description below. Make sure to watch that video in the description. So now we'll be treating some questions. One of the questions we have here says, given an array of positive integers, so this have to be a positive integer. That was a mistake for me. Given an array of positive integers, return the indices of the two numbers that add up to a given target. So this question is actually saying that we should look for two numbers inside of this array that when added together will give us this sum. Let's say in this case it's very obvious. You can see we have 9 and 2. The sum of 9 and 2 will give us what? 11. So first, how are we going to treat this question? First, the way we are going to treat this question is to actually compare every pair in this array. Compare every pair in this array. Now, let's take 1 and 3 for example. When we take 1 and 3, 1 plus 3 is 4. We check, is 4 equal to the sum? No, 4 is less than the sum. That is, no, these two numbers cannot what? Give our sum. So when we also check 3 and 7, 3 and 7 is what? 10. It will not give this sum. 7 and 9 is what? 16. 16 is not equal to the sum. 9 and 2 is 11. Now we see that 9 and 2 is equal to the sum. Therefore, we know that arrays, what we learned in the previous video, we learned that arrays are ordered. That is, they start from index of 0, 1, 2, 3, 4. So in this case, the answer will be returning will be an array that contains the index of 9, which is 3, and the index of 2, which is 4. So one way we can solve this question is by using pointers. Pointer in this case, you can set P1 to be at the start of the array, then P2 to be 1 ahead of P1, which is P2 is at the second point of the array. Again, we'll be looking for a number to find. We'll be calculating for a number to find. Our number to find in this case will be our sum minus our norms at P1. So we are looking for a number to find. We have sum, we also have our norms at P. And this pointer we have to be moving. First, P1 is at, when P1 is at 1, we want to calculate for our number to find. P1, sum here is what? 11 minus norms at P1. P1 here is what? The value is what? 1, which is norms at P1 is 1. So 11 minus 1 is 10. So in this case, we want to check, is this number to find we just got now, which is 10, is it equal to our norms at P2? Is it equal to this norms at P2, which is this our number to find? We check, oh, it's not equal. So we move P1 and P2 forward by 1. I don't know if you get it. First of all, we are calculating the number to find, which is this formula, sum minus norms at P1. P1 is at 1, so we take our sum, which is 11. In this case, our norms at P1. P1 is at 1, so 11 minus 1 is 10. So we check this P2. Is the value at P2, is it equal to our number to find? No, it's not equal to, so we move P1 and P2 forward by 1. P1, we move here, then P2 is now here. Again, we calculate our new number to find. P1 is now at 0, so we have 3 here. So 11 minus 3 in this case is what? 8. We check, is the value at P2, is it equal to our number to find? No, 7 and 8 are not equal. So what are we going to do again? We move again P1 and P2 forward by what? 1. P1 will move forward by 1. P2 also move forward by 1. Then we now calculate for our new number to find. So P1 is now at 7, which is our sum, which is 11 minus 7. 11 minus 7 in this case is 4. Then we check, is the norms at P2, which is this value of 9, norms at P2, which in this case is 9. We check, is it equal to 4, which is our number to find? Oh, it's not equal. We see that it's not equal. So we reset our pointers. We reset our pointers. That's we move P1 and P2 forward by 1. P1 is now at this place, then P2 is now at 3. So we calculate our new number to find. Our new number to find is what? Sum, which is 11, minus norms at P1. Norms at P1 is what? 9. In this case, 11 minus 9 is what? 2. Now we check, is the norms. We check, is the norms at P2, which in this case is 2. Is it equal to our number to find, which is 2? Oh, yes, we see that it's equal. So in this case, we want to return what? The indices where P1 and P2 are sitting on, which is 3 and 4. So we'll just return the indices of 3 and 4. So we know that this number, 9 and 2, will add up to give our sum, which is 11. So I think this is very basic. So let's code out this solution. Let's code it out. So we have const, to sum. This is to sum. This is a question on lit code. So we have function. We have norms. Then we have sum. These are the two arguments. These are the two arguments we will receive, norms and sum. So first we have to run our first loop. The first loop that will go through the array, which in this case, then we set a variable of P1. P1 in this case will be equal to 0. Then we know that P1 is less than norms dot length. Then we have P1 plus plus. We increment P1. So we know that for every iteration, as P1 is moving, we are incrementing it. P1 was here, 0. If we calculate and we see that we couldn't find our number, our sum, so we have to move P1 forward by 1, which is 0 plus 1 is 1. So P1 was now at 3. If you check this now, P1 initially was at 2. So we know that we couldn't find our sum on this index 2. So we have to move P1 forward by 1, which is 2 plus 1. That's what this P1 plus plus is. We are incrementing it. So again, we know we are having two for loop here. Again, before we write our second for loop, let's see. Do we want to use P1 for any calculation before we start our second for loop? Oh, yes, we see that we'll be calculating our number to find, which will be comparing against P2. So we want to set a variable here, const number to find. I'll just use an abbreviation here, number to find, NTF, which in this case will be sum minus norms at P1. So you see that we are using P1 in this for loop. So that's why we have to initialize our variable NTF here. So again, we have to run our second for loop, which in this case, our second pointer becomes P2 equal to P1 plus 1. P1 plus 1. Initially, we know that, let me explain this. P1 was here at 1. So P2 will now be P1 plus 1. That is 0 plus 1 will give us P2. 0 plus 1 we know is 1. So again, we know that P2 will be less than norms dot length P2 plus plus So we have our first loop, also have our second loop. So we now need to write our condition. Now, if the number to find, which is NTF, is equal to our norms at P2, so we know we want to return the indices of the two numbers, which in this case is P1 and P2. We close our if statement, close our for loop, close the next for loop. Then if there is no number that adds to the sum, we want to return -1. Then we close our final function. This basically is the solution to this problem. And we know that for nested for loop, the time complexity is usually what? O of n squared. So we know that the time of this function is O of n squared, and the space is what? O of 1. So in the next video, we'll be talking about how we are going to optimize this solution in order to improve our time complexity, because as we see, this time is very slow. So I want to thank you for watching this video, and I want you to subscribe to this channel if you haven't done so. Like this video, share this video, and we'll see you in the next video. Thanks.